The objective of this project is to show to the audience how the three laws of Newton work in an easy, funny, and interactive way. Also, we are going to show in it the momentum formula and its function with the marble and the roller coaster. We want the audience to understand what is it about, but also that they have fun by doing it. In this coaster, we will be using our knowledge of physics and math, but mainly of physics, by the formula of momentum and the variables x and y. As momentum is equal to mass times velocity, the x will be the mass and the y will be the velocity of the momentum.
Construction methodology. The roller coaster will be built using the following materials. First, a thin wood base measure of 1 meter of length. 2. Wood sticks of different lengths. 4 centimeters beginning at the largest one. 3. A light bulb. 4. A marble. 5. A hose. 6. A metal wires. 7. Nails. 8. A pulley. 9. An elevator made of domestic materials such as wood or cardboard and a PVC pipe.
We will start by pasting the PVC tube in the base along with the other wooden sticks forming the base of the roller coaster. The PVC tube being the start of the roller coaster. Then we will paste a wooden stick between the two hoses and forming the rails of the roller coaster to avoid the marble to fall and stimulating the architecture of the roller coaster. At the same time, we will build the elevator made of cardboard. We also add a string to the top of the box so we will be able to lift it. This elevator will be placed in the middle of two wooden sticks who are united at the top by the base holding the light bulb, who has a string with a switch that is placed on the floor base of the roller coaster for the purpose of being hit by the marble. The hose will be pasted with a hot silicone and wooden sticks to the floor of the roller coaster.
Our methodology is really simple. We plan on doing a base with a stimulation of where each thing will go before actually pasted to see if the material will fit to our liking and being able to function. The whole project has an understandable quantity of materials, but there are some parts of the construction that are defying the odds, especially a part of the roller coaster where the marble will do a whole spin, which can be difficult and not be able to succeed if the marble does not have enough speed to do it. As we pointed before, the methodology itself is quite simple, and the only thing that could be against us would be the actual law of physics that we are trying to prove. These are our pros and cons.
The pros of our project is it is fun and an interactive way to teach the Newton laws. It is easy to do and can be used more than one time. By making a special inclination towards the second law that sometimes is one of the most difficult to understand, we make sure that the kids will have a clear idea how the formula applied in that law works. It is a great way to show the interaction of physics in our daily life. And some cons are like the structure of the roller coaster can be a little tricky. We must state very clearly how the laws are affecting the roller coaster, otherwise the kids won't get it. There could be some complications if the marble does not go at the right speed when doing the turn, making it impossible to go through it. Our methodology is simple, therefore is foolproof, but at the same time quite traditional and could make it a little bit dull.
The topics that are being demonstrated on this project are the three laws of Newton, but we are going to make an approach on momentum, since that is what allows them to make all the loops and turns on the ride. Roller coasters build up momentum when they go downwards, and then using that momentum they are able to do all the upside down turns and loops. However, surprising it may seem the velocity needed at the bottom of the loop to make it over the top of the loop is totally independent of the mass. So usually we don't discuss roller coasters physics in terms of momentum. We usually do it using velocity equations, and we derive them using the concept of energy conservation. Momentum, P, is calculated from the mass m and the velocity v as follows: P equals m times v.